So resource management, basically, how do we manage our labor, equipment, and material? Okay. Resource planning makes use of the right amount of labor and equipment and material. Okay. We don't want to have too much labor on the job site. If we do, then our costs are going to be too high. But we also want to make sure that we don't have too little labor, because in that case, the time allotted for us to do it is going to take longer than what we anticipated. So how do we balance these things so that we get a number that works for us or matches what we're trying to look for? We're trying to get the right amount of people on the site with the right amount of equipment and the right amount of supplies all at the same time, so that they come together and we do it at the most efficient process. That's what we're striving for. Okay. So essentially, the functions of project management are planning, scheduling, monitoring, and controlling. Okay? We're going to plan the project, because without a plan, we don't know what we're doing. Okay? We're going to schedule the project so we know the time frame in which we're going to do it in. And then after we have a plan and a schedule in place, we need to monitor the program to make sure that we're actually doing what we said we were going to do. Because it's great to have a plan that says, yeah, it's going to take me 3 weeks to do it, and a beautiful plan out on paper and everything is perfect on paper, and then find out that you get out there and you've only got one laborer and your truck breaks down and all this other stuff, and because you haven't allocated the right resources and stuff to it, and not only that, you went on vacation for 2 weeks, so you didn't know that something went wrong. Okay, so you didn't monitor it. And the reason why we monitor it is so we can control it. Because if we know that something's wrong, we can adjust to fix it. If we don't know that anything's wrong, we can't make any adjustments. So we have to monitor it and control it, as well as plan and scheduling it. So why do we want to plan the project? Well, the plan helps us. Oops, I get lost? Lost in my own notes. Yeah, okay, sorry. Planning basically gives us what we're looking for to set the schedule, okay? It eliminates or reduces our risk, okay? If we plan properly, we minimize our risk, okay? And the lower our risk, the better we can estimate and the more profitable we're going to become, because we don't have to deal with this risk management concept of, just throwing money at it and hope it works, okay? It gives us a thorough understanding of the project. It gives us strategies to get to where we want to do. We can look at different options when we're starting to work this plan together. And it develops the framework that we're going to use to monitor and control. Okay? We have a plan. We know the sequence of things that are going to happen. So we know when something's out of sequence, because we actually had a plan to begin with that told us what the sequence was going to be. So if the steel contractor wants to put the steel into the footings and the footings aren't dug, then we're not in the right sequence, and we should notice that something's wrong. Scheduling basically puts all the items that we put into the plan into a sequence order in which we now have taken time into consideration. Okay? The plan just tells us what we're going to do. Okay? If I'm digging foundations, putting in foundations, I'm going to dig foundations, I'm going to set the steel, I'm going to pour the concrete. I have a plan. But the schedule tells us how long is it going to take us to dig the foundation. We now put an estimate to that time. How long is it going to take us to tie the steel? How long is it going to take us to pour the concrete? Okay? So now we've put some time rates on this with our plan, so now we have a time frame of how long it's going to do. If the time frame says we can do that in 7 days, and our project our contract says it has to be done in 5, then we go look at it and say we're going to have to figure out how to adjust our schedule to make sure we make contract. If the contract says we have 10 days to do it and it takes 7, then now we've got some time in our schedule that is good for us. So planning and scheduling go together. Okay? You can't do one without the other. You can't schedule a project without a plan, and you can't plan a project well without having a schedule, because the schedule also helps with sequencing and things like that. Okay? We need a plan to schedule the work. We need a plan to track the progress of the work. Okay? And we need a plan to make corrective actions when unexpected events occur. When something goes wrong, if we don't have a plan, we don't know what things are affected after the unexpected event, and we don't know what things, we don't even know what the unexpected event, what things it affected in the plan. So we use this as a tool to get us where we want to go. We also use the schedule of the project to communicate our plan to others. Okay? Who do we communicate it to? Well, the general contractor, if we're a subcontractor. If we're the general contractor, we may use it to do our subs. We're going to talk to suppliers, owners, designers, engineers. All these people, if we have this plan, we can provide them with information that says, you know, we're going to need that steel on such and such a date because that's when we're supposed to put it in the ground. So it would be nice if it actually arrived here before that date. Okay, so I can look at it and say, well, I need air conditioning units for this building, and we're supposed to set the air conditioning units on the first weekend in March. But the air conditioning units actually take 3 weeks to be delivered, so then I need to order them at least 3 weeks before they need to be delivered. Oh, but then I find out that not only do they take 3 weeks to be delivered, but they take 6 months to build. So now I have to put into my schedule, you know, I've got to be back 6 months plus 3 weeks to have some time in there to make sure everything went right. So I ordered the piece of equipment to get it to me at a timely fashion. Or, you know, it's not like the fact that I'm 20 foot short of rebar, I can go down to Home Depot and buy a 20-foot stick. Okay? So this plan helps us make sure that we get it. Also, it lets us talk to the owner and make sure that we're in time for his schedule. Okay? It talks to our suppliers so we know when they're going to deliver what we need, so we get stuff just in time or before we need it. Talks to the engineers and designers in case we see something wrong when we're putting our plan together on how to construct it, that maybe we need more lead time, or did they take this into consideration because they don't know that there's a lead time that's involved and we have to make corrections to their design drawings. Okay? And also, it gives us established production goals. Okay? How we make money in the projects we do is how well we produce. The faster we produce, the more, you know, the better productivity we have, the higher our profit margins are going to be. All right? So if we can do something that we thought was going to take 3 days and we had it scheduled for 3 days and we can do it in 2 days, that means that on that third day I can actually send that group to do something else for me that's production someplace else. So it gives me the ability to schedule my people, okay, so that we can complete the project, overall project on time. Because in most cases there's usually a penalty for being late. And in some cases, there's a penalty, there's a reward for being early. So we have to take that in consideration. It monitors and measures our progress. Okay? We can look at our schedule on a daily basis, a weekly basis, a monthly basis, a yearly basis on long projects, and find out if we're on time to complete where we need to be. Okay? So we know where we're going, and are we going at the right pace, and are we going to be there when we get there? Okay? And then when we see problems, delays, you know, the air conditioning unit can't be ordered for 6 months, and in fact they're so busy that, or there was a tornado at the plant and it's been shut down and it's going to take an additional 3 extra months, we can get that information into our plan and make adjustments to our schedule to say we're going to have to do something different now. Or if we're talking about bridges, we could be talking about cantered beams that were actually poured at the plant wrong with the wrong camber in them that have to be corrected. So, but we have a chance to mitigate it, to get us back to where we belong. Okay, the way we schedule depends on what we like to do and how we want to do it. Simplest method is a bar chart, traditional French. Then you have a network scheduling, which is basically called activity on node, activity on arrow, or proceeding diagram method. And then there's linear scheduling. Proceeding diagram method is the method used mostly for construction or activity on node. Very few people use activity on arrow anymore. Bar charts, traditional French, and linear scheduling. Well, let's look at some examples of them. Simplest scheduling at all. I've got a whiteboard. I just write down what I'm doing. You know, ducks. Okay, we just sit down and write it down so we have an idea what it looks like. Okay, another method is we may take a bunch of Post-it notes and write out all the tasks that we're looking for and then sit down and brainstorm with other people to figure out how they're going to go together. Because what this is doing is this is the planning stage where we start looking at the tasks that are involved and putting them together on how we want to go together. Okay? And then once we get an idea of the sequence and stuff, then we can go into this a bar chart. Okay? You can sort by area. So you have different tasks, the time going direction, and where we're going to do them. Another one, this one's basically sorted by subs. Same concept. Time, activity involved, you know, this is preceding order. And all this stuff can be done on computer, and we're not going to go into the computer aspects of scheduling. Okay, we're going to just talk about the general components that go into putting one together and getting it. Which scheduling software you choose to use or what you want to use is going to be based on you. There's several of them that are very good. Microsoft makes one that's pretty simple to use. The one that's used by the Corps of Engineers and is required on all their projects is called, it's a SureTrack project called P3. It's made by Primavera, and actually it's P6 now, is the latest effort of it. And the initial one that they made was called SureTrack, and it's the most simple and basic one. If you can learn how to use SureTrack, you can run all the other Primavera products. Okay? So another one, detailing out subs. Okay, benefits analysis. Simple, fast, easy to understand. Time scale relationship is visible. We can see the time scale. You know, user friendly. You can see what the time scale is, you can see what the task is, and you just fill in the blanks as you go along. Pretty simple to and easy to use. Okay, some of the cons. Scheduler's knowledge base limitations. Okay, it's not as flexible as you think it is to do a bunch of things with. No logistic relationships. We don't see what the interrelationship of one piece of the project to the other. We're not seeing how they're related. It's not logic driven, okay? So it's hard to update it with progress because it's just a task-oriented chart that says I have these tasks and I need to figure out what goes with which one. No numeric calculations or durations. We're not tracking how long we actually set aside for this. We didn't put in an early start, a late finish, and things like that, so we can make changes on it quickly. And so easy come, easy go. Easy to use, but not so advanced that, you know, we can't do other things. This is a PERT chart. Now, with this, it's the same thing. Each one of these boxes has the task involved in it, but now we start to see days of how long the start is, when it's supposed to start, how many days it's going to be, the duration, and we see interrelationships. We see these lines that connect, dashed lines, solid lines, okay, that tell us that one's directly related to it, the other one's semi-directly related to it, And with PERT charts, we get some flow, we get some understanding of what's going where. We can start looking into critical paths and things like that to find out what we're looking for, to make sure that we're staying where we're supposed to be. But this is a time logic scale with SureTrack. This is essentially, you can put this into SureTrack and then you can kick that PERT chart comes right out of it. It makes both of them at the same time with this program. So CMP that we talked about and PERT, pros, logic relationship, great. You know, it's got, you know, what comes first, what comes second, what comes third, and how they're related. But requires well thought out relationships. So you actually have to think about what you're going to do. You can't just list all the activities down and say it's good. You have to get an idea of what comes before what and what follows what. Okay? Logic driven, updated by numeric calculations with remaining duration. Simple process. The computer updates the stuff. As you click and go through it, you can say if I'm 2 weeks in, you can mark that you're finished with 2 weeks worth of work. It'll go through and recalculate all your durations and say what's done, what wasn't done, what needed to be done and didn't get done. You can look at lots of different things and let the computer do it for you. Okay? Okay, again, scheduler's knowledge-based limitation. If you don't know how to use the program, it doesn't do you any good. Okay? If you can't figure out the logic of how things go together, you know, if you don't know that steel goes in before you place the concrete, then it doesn't do you any good to schedule. And don't laugh, I have students that don't know that sometimes. Usually freshmen. Okay? It's not user-friendly. Okay? You actually need to take a class on how to do it. You know, we teach a class solely developed to scheduling. Okay? 16, 18-week class in which you learn how to schedule by hand and you learn how to schedule with a computer. It's not easy to understand at a glance with no time scale relations indication. You know, you're just looking at it. You can't really tell if it's time related or how it is. So unless you have knowledge of how it works, it's difficult to look at it and say, oh yeah, I understand where we're at or what we're doing. Okay? So here's some different ones that we're looking at. Now the joy of it is you can sort by subs, set it up here with different sorts, different aspects. You can see here, this is one where they're showing, this is where it started, this is where they're at. So the items in green are showing you things that aren't completed. The items in blue say, yes, we're done. The items in red are the critical path. It lines it all out, tells you what's critical, what's not critical, what's been completed, what hasn't been completed. But unless you know what all those little forms and signs mean, it doesn't really do you good. Okay? Here's a 4-week window. We're looking at just 4 weeks of it. So this computer program gives us the ability to look at short periods of time, short interval scheduling, sequence scheduling to see how things are going in the right order, summary by area. These are all different things that we can do by floor. Okay? Again, schedule and knowledge-based limitation. If you don't know how to use it, it's not going to do you any good to try to use it. Okay? It's not user-friendly. We talked about that. Or it might go backwards. No, that's the right one. Okay? There are safeguards built in so you can't do certain things wrong. So if you try to plan something that logically doesn't belong in the sequence, the computer won't let you plan it, even though you know you can do it. Okay? So it's logic driven. It makes sure that you don't make mistakes, but it also doesn't allow you to trick the computer to allow you to do certain things that you actually know you can do. Okay? So it doesn't take into consideration the fact that, yes, I know that it's going to take 12 hours to do that, but I can do it in 10, but the system won't let you change, it won't let you work in days for one thing and hours for another. Okay? So I can't look at the project portion of it that says these are things that are scheduled that it's only going to take 2 hours to do this, but I have to put it into the schedule as a day, so it's telling me that there's a day's worth of work there that's not there. I know it's different, but the computer won't let you tell it different things. You have to work in the right time scale. And then this is a linear schedule, and mostly they're used for highway work. And since this is an ODOT class, this is probably the best set of schedule that you can work, because you can lay out different, because in most ODOT projects, more than one thing is going on at the same time. You know, we're putting down sub-base as we're grading earthwork farther down the line, or we're building bridges as we're building subgrades. So we can look at it in a linear progression of how we need to get to where we want to do. So we can see at station 50, the following items are going to be going on at the same time on certain days. You know, here we do the stripping and the survey and layout, but on day 15, we're actually paving at that same station. So linear lets us look at it as we're going down the line. It works really good for highway projects, streets, things like that, but not very good for buildings. All right, so we have a schedule now. Okay, so now we want to monitor it. Okay, so we must look at the progress on an ongoing basis. Okay, we want to track the time. We want to track our resources. Have we, you know, we had 36,000 square yards of sod to go down. We've put down 38. Is there a problem? Yeah, we've put in more resources than we actually needed. So and we want to check the budget. We can, and a scheduling program will allow us to do that, because you can actually track all these things in different sections of the program depending on how you set it up. And then we're going to control it. We see things. What this helps us do is look ahead to see problems that are coming up. What the schedule does is we start seeing that we're behind time on the bridge abutment fills, which means we're supposed to have the piers, you know, done in 2 weeks, but we're not going to get to the point where we can even put piers in 2 weeks. So we need to call the pier contractor and put him back. Or a good example, a better example would be, we're dealing with a railroad, and railroads are really great to deal with because they own the world, in their opinion. But if you're building new rail track, okay, you don't get to put the rails in for the train. Okay, the railroad company sets all that stuff, and they have a machine that'll come in and lay the ties, lay the rails, drive the nails, and do everything perfectly. You build all the way up to that point, and then they take it. But that machine is so costly and always in use that you have to hit its schedule. Okay, so if you're not ready when it's ready, your project is not going to be delayed a day or two, because that's how long it takes you to catch up. You could be delayed 6 months to a year because it's going someplace else if you're not ready for it. Okay, so this would allow us to see, you know what, we're behind schedule, we're going to miss this date to use this piece of equipment. We better figure out a way to get going faster. Okay, so we can control it. We can adjust the project goals and get us back online. Okay, so planning and scheduling basically involves breaking down and analyzing project, estimating the activity durations, how long it's going to take us to do something, developing the project plan, because once we have all the activities figured out and we have the durations that we can go, we can start putting them together to figure out how they're going to go, and then we schedule the project. Okay, because once we know the durations and the resources and everything, and after we've put the schedule together and scheduled it, then we review and analyze it. Because does the schedule make sense to what we're looking for? And then we implement the schedule. So we're going to break them down. We're going to look at what's involved in the project. We're going to include all the general, supplemental, and specific conditions. We need to look at all the conditions on what's going to be there so we make sure we get everything involved into it. We need to identify the activities. What do we mean by an activity? Well, an activity, and I'm sure there's another slide in there to tell us what that is later, but an activity is essentially an item that we're going to do. We're going to dig a footing. That's an activity. And then, but we also may break it down into even smaller activities. What are the activities in digging the footing? Well, or building the footing. It's digging, steel, concrete. So that's what an activity is. An activity is something that holds merit. Okay? So we estimate activity duration. The duration of how long it's going to take us to do something is going to be based on the labor, the material, and the equipment that is involved in doing it. Can we get all those things there at the same time? If we want to move 100,000 yards of dirt and we're going to do it with wheelbarrows, we're going to have to need a whole bunch of laborers and a whole bunch of wheelbarrows, okay, because we know how much the material is. And the time frame involved in that, now we can estimate how long, because we can move a wheelbarrow 20 or 30 feet in an hour, or however, depending on how big the wheelbarrow is. So, but, it's an exaggeration. We also may start looking at other means. We're going to use shovels. We're going to use trucks, shovels and trucks. We're going to use scrapers. How are we going to put it together? Okay? They should reflect the planned resources. What do we have available? Now, initially when you do planning and scheduling, you automatically assume that you have unlimited resources. Okay? That whatever you want to do, you're going to have. But in the real world, that doesn't happen. But when you start trying to put together plans and scheduling, you start looking at the fact that, yes, everything's going to happen at the same time, and then you can start looking at, once your plan's together, what really is not going to happen at the same time. Or, I can't have my finishers on 2 different pours at the same day. Okay? And then these activities, durations are also used to monitor. We know it's supposed to take 10 days, so if it didn't take 10 days, if it took 11 days, we know something's wrong. If it took 6 days, we know something's right. It helps us monitor getting these durations. Then we develop the plan. Okay? We have an activity, we know what comes before this activity and what comes after this activity, and we can start putting them in sequential order and along with the durations. Okay? So now we're getting a time scale going together. Okay? We're getting item 1 followed by item 2 followed by item 3, and it's 3 days, 5 days, 7 days. So now we know, gee, we're out 15 days. Okay? So now we have this plan, we've put all the pieces together, we've figured out, what, I can pour footings, I can dig footing 3 while I'm placing the concrete for footing 1 and putting the steel in for footing 2. We start to see a sequence of what's going to happen and the logic on all these different things and trying to get them together. Okay? So we can put the schedule together. We can put this information into whatever software we're using, and it'll start putting it together to show what we're doing and how we're doing it. Okay? Now, we have to assign start and finish times to everything that we're doing. Okay? I'm going to start at this date and I'm going to finish at this date. The computer also does that for us. Once we know what start date we're going to have, if we start it and we set that as day 0, and 1, 2, 3, 4, like I said, it will tell you that the start date for item 2 is 3 days after item 1 started. And the start date for item 3 would be, what they say, 3, 5, and 7. Okay, it would be 8 days. It starts at day 8. Okay, so we put these activities in with the schedule. We assign starts and finish dates to it. If we need to start and finish at a different date, we actually assign that date to it. We can set the date which we want to start at if it's different than what we're looking at. Okay, now we have the schedule. Again, great. We have the ability to monitor and control our progress. We've got something to look at that says what we're doing. Okay, so we put together a schedule. It spit us out, gave us that little PERT chart, showed which item goes to what, and all this other stuff. Now we have to analyze it. Does it actually make sense? Did we put it together right? Okay. Have we put the items in there in the right order? Okay. Is the sequence that we want to use correct for all items, or do we want to do something different? Do we see things that are doubling up on themselves? Do we have logic problems where we have the same thing going over and over and over again because we forgot that something had to happen before we could do that. So there's a logic loop in it. Okay? Once we analyze the problems that that simple concept. We decided we wanted to pour the concrete before we put the steel in. We just wrote it down wrong. Well, we get to make that change right now before we actually implement this schedule. And once we have the schedule put together and we start to implement it, we must constantly be reviewing it, looking at it. Now, do we have to look at it every 15 minutes? Do we have to look at it every hour? Do we have to look at it every day? Do we have to look at it every week, every month? Well, that's a function of, one, how OCD you are, and two, what you need to do to maintain this monitoring and controlling subject. Okay? And then we implement it. We hand it out. Yes?
Usually you do schedules previous to the bidding process. That's one, we do the baseline.
Right.
And then you can lose the bidding process if you don't do it right.
Right.
And then you implement it in the building, so you have an as-built, which is the one that you're going to be implementing.
Right. Yeah. He's making a very good point. Scheduling is not something we do once we get the project. It's probably something that we did during the bid for the project. If we do the schedule when we bid the project, one, it improves our bid because we have the schedule already put together, and two, when we actually get the project, we already have something to work off of. Okay? So we know what we're trying to track, and scheduling is an excellent tool to go with your estimating. Okay? You implement the schedule by basically giving it out to the people who need the schedule. Okay? It doesn't do us any good to make a schedule and have a nice computer program that we get to look at every day on our desk if it's just sitting on our desk and we didn't bother to give it to the people who actually need it. And then we monitor it, manage it, update it regularly, make sure it's doing what it needs to be done. So, here it is again. Breakdown, review and analyze. It's okay? No? Well, let's go back and figure out what we did wrong. Did we estimate activity wrong? Did we develop the plan wrong? And we keep doing that till we get it, and then we get it, and yes, we're going to implement. So off we go. Let me catch up with my notes. All right, let's talk a little bit about activity characteristics. We talked about having these activities. Well, what are these activities? Well, one, they consume time. So if it doesn't consume time, it's not an activity. Okay? They usually consume resources. Our activities involve us having to use something. We're laying sod, we're moving dirt, we're building bridge foundations, so we're consuming resources. They have a definite start and finish time. We know that it has to start on a specific date, or it's going to start, and then after it starts, 3 days later, it should be finished. Okay? So we can assign a time period to it. It has a duration. Okay? Now, a definite start and finish doesn't mean it's got to start on October 15th. It means once it starts, it has to go till it's completed. Okay? They are assignable. We can actually assign them to somebody. We can say that the geotech report's going to be done by the geotech engineer, and that the sod's going to be done by whoever does sod, and the construction is going to be done by the construction company. We can actually assign different, we can assign the footing, the foundations are going to be done by a foundation crew, or the concrete's going to be poured by Cantera Concrete. We can assign the task to somebody in our system, either somebody who is us, in our program, because we're going to do the flat work and the concrete and stuff like that, but we're going to sub out the earthwork. and the steel we're subbing out to somebody else to tie it, okay? Or we assign it to somebody else. So these are characteristics of these activities. It makes it easy to figure out what they do because they are, you know, now. So a start work date or a milestone along the way that says I have to be 50% completion is not really an activity because it doesn't consume time, it doesn't consume resources, and you can't really assign it. It just says it has to be done. But there are certain activities that you can put in there that don't meet this criteria, but usually basically they're start date, finish date, and your milestones that go along the way. They're just a spot to hold up space, but they're activities when you put your program together. Oh, forgot. They are measurable. We can measure the time. If we know that the time takes 3 days, we can measure that we got the 3 days. We know it took 1,000 yards of concrete. We can measure the concrete quantity went in there, or the earthwork, or the sod. So it's a measurable concept as well when we chase it. Okay? Usually we divide activities up into categories when we start scheduling. We start looking at different things. There are things that belong in the administration. There's things that belong in the MOB and DMOB. Procurement, we talked about, you know, there are certain items that we have lead times on. We need to get them way out ahead of our schedule. Okay? The construction phase, and then the startup and testing. That doesn't relate so much to ODOT work as it relates to commercial work, more or less. That's basically making sure the lights turn on, making sure the air conditioners work, making sure the toilets flush, and things like that. But it's part of your scheduling permit. You need to have it in there someplace along the way. And in some functions it could be a long period of time. If you were putting together a power plant, you might actually have in there the training and instruction of all the employees on a 6-month basis that you have to do that before you're going to turn over the project, that you have to train everybody to run all the equipment and do everything. So it can be a substantial time frame in certain aspects depending on what you're doing. Oop. Okay? Divide the project into distinct work items. Okay? Put them together in what belongs. You know, if the foundation work's all here, the earthwork's all here, the bridge work's all here, those are distinct items that we can separate the work in. Where will the work be accomplished at? Multi-phase. If we're on a large roadway project, you know, we've got the first 5 miles, then we've got bridge 1, and we've got another 3 miles, and we've got bridge 2, we've got another 3 miles and bridge 3, and then 5 more miles to where it finishes. Well, we're not going to work on all 3 of those at the same time, but we may decide that we've got 5 different sections or work activities. We've got the first set of grading, bridge 1, the second set of grading, bridge 2, the third set of grading, bridge 3, and we may actually even have the same people doing each one of them, but they're not all going to happen at the same time. Okay? But we want to sequence them in, and some of those things could be going on at the same time. We could be moving dirt on all 4 phases at the same time while we're working on bridge 1 and 3 because that's the way we want to put them together in bridge 2. So we break them down into distinct worked items so that we get all the activities that belong to that particular item together. Now, we may just have them divided on this same project into 2 items. We have earthwork and we have bridge work. And then all we're going to do is just recycle those 2 items 3 different times. Okay? But we want to get them into distinct work groups so that everything belongs to, you know, we don't want bridge foundations with our grading people or something that's out of sequence or in the wrong place. Okay? Who's going to be responsible for it? Okay? So once we figure out what all the tasks are, we start assigning responsibility. Why do we assign a responsibility to these tasks? Well, so we can hold somebody accountable for not doing what they're supposed to do. Okay? That's part of the monitoring and controlling section. When the work will be performed, what order we want it to be performed in. You know, and the order in which we perform work depends on a lot of things. It could be just, you know, I'm OCD that you have to do it in this specific order. If you don't, I'll messed up. You know, you got to put baseboards down before you paint. Why would anybody want to put baseboards down before they paint? I don't know. But if that's the sequence that I have to live by, because if not, I go berserk, then that's what we're going to put in the sequence. So we sequence these things out in the order in which we want them performed. Okay? Now, normally we hope to follow a logical procedure to do it and put them in the right way. Okay? And how this work will be accomplished. Do we need to assign special equipment to different items in our breakdown? Okay? In our plan? Do we have to know that we're going to need a crane for the bridge work to help, or a foundation contractor, or certain different items that need to go into it? We want to start looking at how this work will be accomplished. What we're going to do, because how it's accomplished gives us the ability to assign the equipment and the labor so that we can start calculating the durations. Okay? For our schedule, activity detail, what are we looking at? We're talking about these activities. We've broken them down. We've started assigning tasks for responsibility. We started deciding what type of work we want it done, how we're going to do it. But what are we really looking at? Well, the activities need to be what's necessary for your project. I can't tell you what size activities you need to be or what you want to do. We talked about, we had grading, bridge, 2 activities. We've divided into that. Well, maybe that's a little bit too big an area. So maybe we want it into smaller, the grading, we're going to divide it into stripping, clear and grub, subgrade preparation, cut and fill movement, and those things. Different things. So large or small depends on what the schedule looks like, on how detailed we want the schedule to be. Okay? It just basically gives us better detail for our planning. Okay? If we're talking just 4 different pieces, we've just made, yeah, it's an easy schedule, but we really don't get to look at to see how detailed or when, if something goes wrong, where it went wrong. Because we just divided it into, so if we divide it into a smaller schedule, we get a better chance to look at it. Of course, on the reverse of that, if you divide it into too small a schedule, you're going to get caught down in the details. We don't need, paint baseboard A, paint baseboard B, paint baseboard C. That may be too detailed. Okay? So there's no way we can tell what we want on how big or how small, or by cost. It's just a feel, what we think works for us. Okay? You want to make sure that when you're putting your schedule together, you do have a good description of the activity. Like I said, you want an activity description that's probably good, that's long enough to understand what it is, but short enough so it doesn't take up 6 pages or a whole page of work when you're trying to put your schedule together, or 3 or 4 lines in your computer program. Okay? Should be concise and ambiguous so you know what it is. You need to be consistent. Always use the same, use the same abbreviations for everything. Be consistent in what you say. Don't call one of them earthwork and the other one, giant bridge clusters in which I move dirt over the top of. Okay, that's a bridge abutment. But and when you use abbreviations, make sure you use standard abbreviations. Don't use ones that you know. Use ones that everybody knows, because this schedule is going out to other people. So, if OK to you means just a K, it may not mean that to everybody else. They may think it's a K rail. So you need to use abbreviations that everybody's accustomed to. You assign the responsibility of the activity based on who's going to be doing it. Okay? Document who you assigned it to so that you can hold them responsible. Okay? Make sure there's no confusion about the completion dates and things like that. That's where this clarification is, so we make sure we know what we're talking about. This is not part of a schedule, but it's a work tool that we use. It's called work breakdown structure. Okay? It basically breaks down the project like so we can look at it. Total project, we've got subheadings, and we've assigned different tasks, administration. We look at the construction, we have different seals. We look at the footings, we have this. We look at the placement of the footings, we have what we need involved in it. You can't schedule from this, but you can break down what you need and where it belongs on different aspects. Okay, so you can get a look at who's doing what and what you're doing. So it goes with your schedule. It helps you break down the pieces of it so that you can put them in the right order. Okay, activities have time. We talked about that. They have a duration, a start and a front. Okay, what kind of time? Years, months, weeks, days, hours. Okay, commonly days is what we use. On a large project though, you may put your schedule together, you may actually put your schedule together in each one of those combinations. Years, months, weeks, days, hours, because each one goes to a different person. Your foreman may want to know what's happening on an hourly basis. You want to know what's happening on a weekly basis. Your project manager, if you're the superintendent, you may want to know what's going on a daily basis. Your project manager may want to know what's going on a weekly basis. Your owner may want to know what's going on a monthly basis or even a yearly basis, because it's such a long schedule, he doesn't care as long as he knows what's happening every year. More than likely, you're going to be dealing in months, weeks, and days. Those are the three most common ones that you use for scheduling. Okay? We said we needed to assign not only a time frame that we're dealing with, but we need to get a duration for each one of these things. So how do we come up with work durations? Well, work quantity divided by our production rate. Pretty simple. If I've got 1,000 yards of dirt to move and I can move 10 yards an hour, I can move 100 yards in a 10-hour day, 80 yards in an 8-hour day. If I move it in a 10-hour day, it takes me 10 days to move the dirt. So now I have a duration for my activity of earthwork. Okay? So with this activity and duration, I now have a piece to go to my schedule. I know how long something takes for me to do something. How do we get these things, these production factors? Where do we come up with? It's a simple concept, quantity. The quantities we get off the plans, the production works, we come out from what we know, right? So we've got available resources. We can look in books. What's the nature of the work? Different work takes different things. Some things are more labor intensive or time consuming than others. The labor and equipment productivity. How fast do our people work? How fast does the equipment work? The excavator may be able to move 100 yards an hour. The trucks that we have can only move 50 yards an hour. So we either need to get more trucks or we could get by with maybe a smaller excavator. Management skills. Do we have the ability to schedule what we're trying to do? Are we a manager who knows what he's doing, or are we a manager who comes out, tells everybody what to do even though we don't have a clue, and then leaves? Had a superintendent that swore he knew how to move dirt. And at least once a month he would come out, jump on a dozer, and run it till he got it stuck and say, see, that's how you do it, and leave. Messed up the productivity of the whole group because he didn't know what he was doing. He just thought he knew what he was doing. And he didn't like what they were doing. And he thought if he just ramrodded it down their throat, they would go faster. Well, not only did they not produce as much, they lost time because it took them another 2 hours to get the dozer out before he got it stuck.
Get a dozer out in 2 hours?
Well, yeah. Or you have workmen. I worked on a project where we were that dealt with bay muds, which is a really soft mud. The scraper operators were told to keep the scrapers out of there. They would doze the mud to them so they could pick it up. Scraper operator decided he knew better and drove into the bay mud. 3 hours later, and several pieces of equipment, they pulled the scraper out. The gentleman hopped in the scraper, turned around, and drove it right back in the same hole it just came out of. So sometimes it just doesn't make a difference. It had nothing to do with management skills, had everything to do with the operator. Materials and equipment available. Do we have the equipment or the materials to actually do the production rates that we want to do? You know, I want to lay 1,000 square yards of sod every day. Can the supplier actually provide me with 1,000 square yards of sod every day? Or do I have to go to 2 or 3 different suppliers to get that much material there? Or do I have the sod laying equipment to actually lay that? Just because I want to do something doesn't mean that I can do it, because we may or may not have the equipment or materials. We talked about the truck example. I can dig 100 yards an hour, but I can only haul 500 yards an hour. I have the ability to do the 100 yards an hour that I want to. I just don't have the trucks to do the 100 yards an hour. So the equipment's not there, or the material's not there. We can't, when they did the Devon Tower pour for the foundation, they had 3 batch plants online. So they made sure they had all the concrete. And one of the batch plants online was just there as a standby in case one of them broke down, because it was a massive pour that could not be stopped once it got started. The weather conditions make a difference. If it's raining and muddy, I can't move dirt, no matter how much I want to. If it's dry and dusty, I may not be able to move dirt because I don't have a water truck available. Work restrictions. I can only work between 8 and 5. I can't work on Saturdays. I can't work on Sundays. The quality of work. How good am I going to do it? Do I need to make pool table type levelness across the subgrade, or am I okay if I'm plus or minus a tenth, which is what the specs say? I've got a blade operator who wants it as smooth, as smooth as it possibly can be, versus plus or minus a tenth. It's close enough, guys. Speed up your production. And concurrent activities. Can I do 2 things at once? Okay. Can I be drilling piers and building bridge abutments at the same time? Maybe not, because we're both in the same space. Or a better concept, which probably doesn't relate too much to ODOT work, but working above yourself. Okay. If I'm building a building, I can't be pouring concrete on the 2nd floor and framing on the 3rd floor above me. Now can I? Because I've got people above me that may be dropping things down on top of me. Okay, so concurrent activities make a difference. Or I just don't have the equipment to do both things. Okay, what resources we have available? Labor, equipment, materials, subcontractors and suppliers. Okay, activities are resource driven. If we don't have the resources, we can't do the activity no matter what. So we have to assign our resources as well as work on these durations. Okay, and the scheduling program will allow us to do that. We can actually assign resources in our programs and say that this is what we've got, and it will help us sort out when we have problems. Okay, if your durations are not resource-based, they're not going to be very accurate. If you think that, oh yeah, I know I can move 100, my excavator moves 100 yards an hour, so we're going to put 100 yards an hour into our program. But you don't take into consideration that your trucks can only move 50, and you're not going to get more trucks, then your estimation and your information is invalid. Garbage in is going to give you garbage out. The nature of the work, what we're doing and where we do it. The more experience we gain in doing things, the better off we are doing it. So we can reduce or make our production rates higher because we have better experience at it. The less we've done something, the lower our production rates are going to be. So we gain from experience. Labor and equipment productivity, training, experience, motivation, labor restrictions. You know, how motivated am I to work? You know, if you're working your crews 12 hours a day, 7 days a week, they're not going to be as effective as they were if they were working 5 hours, you know, 5 days a week, 8 hours a day. Or, you know, out in California one summer, they were just swamped. So much work going on, they were working 7 hours a day, 7 days a week, 12 hours a day. And they were, you know, getting tired and started knocking down grade stakes and stuff like that. And the foreman came out and said the next guy knocks down a grade stake is going to get 3 days off. And 3 operators ran over grade stakes, got off their trucks and went home. They were motivated because they wanted the day off. They didn't care about the grade stake. Okay, so if we don't, and that's a management skill. That comes from working our people and helping them do that. What time are we supposed to break?
Any time's good.
Okay.
We can get to a comfortable break place.
Well, we're just basically going through these different items that we talked about. Manage your skills. Let me get through these and then we'll take a break. Because I'm trying to figure out where I'm at. I've got like 105 slides. And like he said, we're engineers, so I actually calculate how many slides I can do in an hour. For lecture purposes, I've always done that. That way I know I have enough slides to cover the hour. Management skills. We're talking about to plan and organize. If I don't have any idea how to plan and organize, it's not going to do me any good to put together a schedule. I'm not the right person for the job. You know, so you may innovate. The other concept is you may also be looking at people that can actually look outside the box with their management skills and think of different ways to do things so that we can get it better. And like you said, in most cases, if you come up with an innovative way to save money for your client in today's world, in most cases, one, you either get to stick it in your bid and save the money, that's good for you, but in most cases, a lot of times, especially if you're already in the project, you go to your client and say, I can save you money, they're going to give you a piece of the savings because not only do they save money, but you save, you know, so you deserve something for it. So in a lot of cases, it's good for you to be able to think outside the box. Now, I'm not saying everybody gives you back money because you can save them, but especially with ODOT, they're going to look at that, you know, and government entities are constantly doing that kind of stuff. If you can come up with a way to save them money, they're likely to reward you for it. You know, we talked about equipment and materials. We went through that basically. You know, raw material available, credit restrictions, delivery. Those are things we have to think about when we're trying to assign this resource or come up with these durations. Can we actually get what we want? Can we buy what we want? You know, in today's tight credits concept, I may not be able to borrow money to buy the sod that I need because I've bought all the sod I've got and it's already on the ground and I haven't got paid for it yet. The seasonal conditions, there's not a whole lot we can do about weather. We don't control that. You know, I know that my connections with the Almighty are not good enough to ever change the weather, and I don't think anybody else's that is. So we just have to work with it. You know, you deal with the fact that on hot days your production is going to go down, and on cold days your production is going to go down, and hopefully you get to work. You know, you can adjust some of that stuff. You see a lot of concrete pours poured on 100-degree heat days here. They start at 2 o'clock in the morning. You know, so we make adjustments to compensate for the fact that what we have to do. Your work restrictions, basically, we talked about those. Delivery, limited work hours. Quality of work. High quality and tighter tolerances take more time. So you have to determine what stage of quality do you want? The minimum, the maximum, someplace in between. You know, that's a function of what your owner wants and you know what the specifications say. We talked about concurrent activities, something on top of you, something below you. Or I need to dig a utility trench while I also need to dig a stormwater trench. Well, I've only got one piece of equipment. It can only dig one or the other. Okay? But they're scheduled to go at the same day, at the same time. Well, those are concurrent activities that won't work. You're going to have to adjust your schedule. One of the things we have to make sure is whose takeoffs are they? Are they engineers' takeoffs or are they our takeoffs? And do they match? Because if we don't check them, we could find that the engineer made a mistake and has a lot more, and there's more in there or less in there that we need to be able to take advantage of. The bid estimate provides us with that information. Past experience in our production, what we've done in the past, will tell us how fast we can produce and what we think the quantities we can haul or things like that with the equipment that we're using. Outside information, we may go to a CAT handbook because we're going to get a brand new scraper, one of the new auger type scrapers. We don't have any idea how they produce because we've never used one. Estimating guides, means, there's several different estimating systems out there, books that are made that you can just go in and look to figure out and then you can ask the industry and trade organizations. They have that information too on what they think production rates are for things, especially, and the estimating guides and the industry and trade organizations are good aspects to get information from for things that you don't know, you've never done before, okay? Manufacturers, fabricators, and suppliers can also give you ideas of how long it's going to take them to actually fabricate the steel that you're looking for. Or do the beams on a bridge, the camber in them to make sure they've got the right camber, the pre-stressed beams that you're going to use, or the steel. And then your specialty contractors. You know, a pump truck operator is going to know better how his pump truck operates than you are. Okay? Or the crane operator is going to know how the crane works better than you do because you don't run a crane on a regular basis. It's a specialty contractor. Okay, some rules for activity durations. How do we come up with them? Well, first we want to select the time unit for the project. We need to decide what we're working in. Years, months, days, weeks, hours. And we have to be uniform. Everything has to work in that duration. Okay, we want to evaluate each activity independently. Even though they're interrelated, we want to figure out the production rate for the earthwork, okay, different than, or a better concept, the caissons that we drill. In most cases, we drill the caissons and then we pour the concrete same day. But they're two different operations, and the supply chain may be different on each. Okay, he may be able to drill, 10 foot an hour. The concrete supplier can supply us 100 yards of concrete an hour, but they don't work they're two separate and independent concepts. So when we start looking at the activity and the production rates on them, we want to calculate them separately unless they're combined together into the same activity. So each activity has to have its own independent duration, and we want to evaluate it by itself so it stands alone. Even though we want to evaluate the digging of the footing, the placement of the steel, the placement of the concrete. All three of those go into the placement of the footing, but each activity needs to be independently done. We don't worry about when one, Okay, we make an assumption that all the resources are available to us. And the reason why we make this assumption when we're doing our initial scheduling and stuff like that is because we can't start, we assume that all resources are available to us. It gives us the ability to set the durations and activities uniformly, and then when we analyze it, we can go back in and figure out which things we really can't do, or when we double up on projects and stuff like that, it helps us make that. We know that this is not going to actually happen in the real world, but to put your schedule together, you have to make that assumption so that you get accurate times to start with, and then you can work backwards. Okay? Assume a normal level of activity. We don't want to put in there, if our normal level of activity is a 10-hour workday, then that's what we're going to make the assumption on. But most people work 8 to 5, 5 days a week. So they work 8-hour days, 5 days a week. That's what we're going to put in there as our assumption on our level, unless we do something different. But we want to make sure it's uniform for everything. Assume a normal work day, 8 to 5, or 8-hour day. Assume a normal work week, 5 days a week. Okay. How can we improve these durations? Well, we can divide them into smaller activities, right? We break them down into smaller activities, we got more control over it. Okay? We can use several sources of productivity info. Don't base it just on one thing. You know, my past experience is that we did it in, we placed 100 yards an hour. Of course, that was on a job in which we were digging sand and placing sand back in the hole. This project's going to be on clay, or it's on clay sands, or it's going to be something different. So let's look at our productivity rates over several different items that we've done, or several different sources if we don't know what we're doing to come up with this productivity. Avoid biases when estimating duration. Don't think that just because, you know, I know it says that that in the past we've done it at 150 yards an hour, but I really think that we can do it at 125. So I'm going to add that into the system. Even though we've never done that before, I really believe that that's what we ought to be doing it at, so that's my bias that I'm going to put in. Or, you know, I want to sandbag the system. I really need a few extra more days, so you know what, I'm going to bias it and say, really, we can only do 200 yards a day, even though I know I can do 150. That way, I've got a few extra days in my contract because I really know that I can do it faster than that. Okay, but by biasing it, you've already put, you know, just like what he was talking about with contingency funds. Because we knew we could spend it, we spin it. So if I bias it by saying, you know what, I really want to do, you know, I'm going to put this extra 50 yards an hour in there, that means I get an extra 3 or 4 days out of it, you're just going to eat those 3 or 4 days up because you know they're there. Okay? And that doesn't help you with your schedule because what you thought was free days, you knew were there, so you know, it's like setting your clock 10 minutes ahead. You always know it's 10 minutes ahead. So you show up late anyway, you know, because your clock said you were late.
If you use critical path, wouldn't that eliminate that?
Well, not if you put that into the duration. If I skewed my duration and added an extra 5 days into it, it's going to increase the, it may put that on the critical path that says there's extra 5 days there that's not really there. Or if I biased it the other, especially if I biased it the other way, said, you know what, we can actually do it faster than that. Now I've shortened my critical path, but and especially if it's on the critical path. Now if it's not on the critical path, say it was off the critical path by a day or two, but because you biased it by 2 days, it really should be on the critical path and it's not, because it didn't kick in when you hit the scheduling button. Okay? Continually review and update the activities during construction. By doing so, we keep control of this schedule. We make those adjustments. We can pull out the days that we don't need to. We can add the days where we need to. Okay? Bring the people that are responsible for doing the work into your scheduling process. Don't assume that you know how many days it's going to take him to do the work. Ask him. Okay? How many days is it going to take you to lay the sod? Because I've got 5 days in the program, and it's 100,000 yards of sod. Can you do it in 5 days? Yes or no? You know, they're going to know that. Or, you know, I put 1 day in there for seeding, but it takes me 3 days just to prep. So get the people that are going to be doing the work. And by having those people's input into the schedule, they now have a buy-in. Because they put, when they say, well, I can't do it in that amount of time, the answer is, well, 6 months ago when we put this together, that's what you told me you could do. So now they're responsible for it. The time convenience, what you're going to look for, okay? Essentially, in a schedule, all we're talking about is it's expressed in work days, the days we actually work. Our time schedule, how many working days we have doesn't actually reflect how many calendar days we may have. And we express completion in times of days expired. Okay, so what we've already done, not what we're looking to do. And so which means we have to have a beginning day 0. Now, what does that mean? Is day 0 the first day I do something? Or is it the end of the day I have done something and it starts, the computer thinks differently. It's either 0 day is it starts at midnight and it's all that time for that 24 hours. So is it starting at the beginning of the day for my day 0, or is it starting at the end of the day for my day 0? You see what I'm getting at? It's difficult to see if you're not using the program. But some programs say that day 0 is at the end of the day. So if I'm going to start, day 1 for the next project would actually be the next day, because this is day 0. Or other programs say it starts at the beginning of the day, therefore this is day 1, even though we're not really doing anything until tomorrow, because the way the schedule's set up, or the way its time configuration is, it makes that. And the program will make that decision. If you're scheduling by hand, it's not that big of a deal.
Scheduling by days and not by hours?
Yeah. Yeah, well, also, yeah, because days, that's a prime example. Something that takes you 2 or 3 hours to do is in a schedule is a 1-day basis. Okay, so even though it only took you 4 hours to do it, it's still in there as 1 day, and you may have 2 or 3 items on the same 1 day, because the first one takes 2 hours, the next one takes 2 hours, the next one takes 2 hours, and the last one takes 2 hours. And so I've got 8-hour day in there, and each one of them say 1 day into my program, but they didn't take 1 day, they only took a portion of the day, but we can't schedule in portions of days. So the calendar that we select makes a difference on how we're putting this stuff together. It assigns the days, because we have to take into consideration other things. What days we start, rest days, Saturdays and Sundays. If we're not working Saturdays and Sundays, those are rest days. Holidays, and work days. Now, we can set the schedule up in a variety of different ways, but if we don't, we need to know how to set this up, and a lot of that's going to be based on what the contract says. Is the contract 365 calendar days, or is it 365 work days? Because there's a big difference between those two, right? If there's 52 weeks in a year and I take off 2 days a week for rest days and another 10 days for holidays, I've just taken 100 days out of my 365-day calendar. And if I thought that I was working on a 365-day calendar and I was working on a 200-day workday, I may not have enough time. Okay, so we want to take those into consideration. The project start date is the earliest time in which an activity can start. Okay, so that's why we have this sequence. We know that activity 2 can't start till activity 1 is completed. So if activity 1 takes 3 days, then the earliest activity 2 can start is day 4, right? So we look at those things and set that up. And if we have multiple points, okay, if multiple things have to occur before we can start, if activity 3 is based on activity 1 and 2, and activity 3 takes 3 days and activity 4 takes 4 days, but they both start at the same time, what's the earliest activity 3 can start? It can't start till 4 days, because that's the controlling activity. So you have to look at everything that feeds into what we're doing. Okay? And it's important that we set this up right because everything that we do feeds into it. Okay? If we set the wrong start date, everything's going to be off. Okay. We've got our schedule, we put it together, we understood we got the production rates. Now we want to review it. Is it complete? Do we have everything in it? Did we leave something out? If so, let's go ahead and put it in now. Okay? The work descriptions make sense. Do they match the scope of work that we're doing? You know, is our job to move 1,000 yards of dirt and our schedule is based on, well, first we need to count 500 jelly beans, you know, and then separate them by color? You know, do they relate? Did we set a schedule up based on what we're actually going to do? And does it work to the scope of work? Are the activity durations reasonable? Do we come up with durations that make sense? You know, we decided to paint this room, it was going to take 10 days. Does that seem reasonable from our experience of painting rooms in the past?
It'd take me at least that long.
Yeah. A function of how good a painter he is, it probably would take me 10 days too. Probably take me 9 days to look at it and get around to figure out I want to paint it and another day to paint it. But because I have to be done in 10 days. But are they reasonable? Are they based on the quantities of work that we're looking for? Do they make sense to us? Are the relationships complete? Do we have everything that we needed to go into it? If we're talking again about painting the room, in our activity assignment, paint the room is the last thing. Did we put in the fact that we need to tape the walls? We need to remove, you know, put down coverings to protect the carpet. All the other things that need to go with it, did we get all the things that go with it before we can actually start it in place? So is the relationship activities complete? So if we left out a necessary relationship, we're going to have a problem in our schedule because we can't do what we want to do because we left out a piece that said buy paint. Okay? You know, we thought of everything else. We just forgot that we actually had to buy paint to paint it. Okay? And are they valid? Okay? Do they really make sense? Do they go together with what we're trying to do? Okay? So they not only do they match, you know, they all feed into what they say, but is it valid? If we're talking about painting the room and one of the relationships we have to it is to check the weather outside, is that a valid activity in our relationship to painting the room? Not particularly. But it may be if we have some excuse that says this is not an air-conditioned room, we have to have certain ambient temperature to paint in, and so we need to make sure that the weather outside is such that it's not 100 degrees in here when it's 120 outside because the paint won't work. But we want to check that out. Does it flow? Schedules have flow to them. They start at one point and they go to an end point. Okay? So if we have something that goes in there and all of a sudden comes back to 3 or 4 weeks past this, there's something wrong with our flow because we're going down and all of a sudden, you know, oh, by the way, I need to go back to 3 weeks and start this. Well, that's not flowing right. Something's wrong. So they need to start from the beginning and flow to the finish. Okay? When we have concurrent activities, are they going to conflict? Do we have two things that, you know, and it's not unusual for schedules to have concurrent activities. In fact, most schedules have concurrent activities. Only small, really relatively simple schedules don't have concurrent activities. You know, if it's a one person, one thing schedule, the likelihood is no, there's no concurrent activities. But in most projects that we're dealing with, we have multiple crews. You know, we may be placing sod on mile 1 and we may be prepping sod for mile 3, prepping the ground. 2 different crews. They're both happening at the same day. They're concurrent in our schedule. Do we have enough bodies to cover them? Are they causing us any problems? Check for safety conflicts. We're going to be working underneath the bridge deck, and they're going to be working on top of the bridge deck, laying steel or putting up formwork. Is there an excessive amount of work? When we put these schedules together, we have assigned durations or time frames to them. So we can use that schedule to tell us how many hours we've got. You can actually, in the computer programs, you can actually go in, and if you assigned your resources right and did the right thing, you can actually look at how many hours you've got scheduled. If I've got my crew scheduled to work on this in this week for 300 hours, but I've only got a crew that's, I've only a 5-man crew that works 40 hours a day, 40-hour week. So at best, they can do only 200 hours worth of work that week. 8 hours a day, 5 men, 40 hours times 5, 200. But we've got them scheduled for 320 hours worth of work. Is that going to work for us? No, it's not. We're going to figure out, we're going to have to adjust our schedule to compensate for that. We can't work too many days. Is the calendar correct? Did we choose the right calendar? Okay, is it scheduled day by, because if we chose the wrong calendar, if we're dealing with months and we really need to see it in weeks, or we're dealing in weeks, we really need to see it in days, we need to make sure we have the right calendar put together. Or, same token, if you're working in England and you set up a schedule, the day after Christmas is a holiday. It's called Boxing Day. But if, here it's not a holiday, so we would assume that we're going to work it, and I set my schedule up to work it, and by the way, we're not working it over there because that's not the right holiday. It doesn't fit into our schedule. So different areas where we work may, August 1st in Colorado is a holiday. It's the day the state became a state. So if you go up, work in Colorado, you're going to get the 1st of August off. So you need to know to make sure you have the right stuff. Simple concept. Is the schedule duration within the time frame that we have? If I put my schedule together and it says it's going to take me 365 days to do it, and my contract says I've only got 200 days, what good is my schedule? Okay. Yeah. So it needs to make sure that it's in the right time, so it makes sure it works, so you can figure out what you did wrong. And then, are your contract milestones met? Did you meet the points that you needed to do? And milestones aren't really activities, but we put them in there because they're things that we may have to do to make our contract. We have to have this bridge open at a certain date because that's the way they want it. Or we have to have this bridge completed by a certain date because the rainy season is going to start and we need to be able to get over it because we can't ford the river once the rains start coming. Okay? Is the critical path reasonable? Okay? What is the critical path? Well, that's the path in which it goes through all the activities that are required to get completed to get us from start to finish, that all have zero float. Okay, and I'm not going to go into the floats and things like that, but essentially it means that if I don't get this done in the right time frame, I'm going to be late. That's the critical path. Anything that's on this critical path means if it doesn't get done when it's supposed to get done, we're behind schedule automatically. Okay. Are there multiple critical paths when you analyze your schedule? There should only be one. If you've got multiple critical paths, you've got a problem because you've got too many things going on at the same time. It's not to say they can't be done, but it's not a good deal when you set your schedule up. Okay? Eliminate them if possible. And then we also want to know what activities are near our critical path. Okay? If an activity has a one-day float in it, okay, if something goes wrong and we lose that day, what happens? It's now on the critical path. Okay? So the time frames in which we allocate how much time we have it, if we use up the extra time that's free, that's not on the critical path, then we've put it on the critical path. We've put something there. So we want to know, we want to be able to, not only are we monitoring this critical path to make sure we hit the right time frame, but we want to look at the things that are near it. So when something goes wrong, not if something goes wrong, it's when something goes wrong, we can make that adjustment. Because something's always going to go wrong. Okay. This is just a trick that you can use with your scheduling. You can level the schedule details. So you basically go in and adjust things so that you make it more level. You smooth it out. Who's going to use the schedule makes a difference on the level of detail that we're looking for. You know, how detailed do we need this schedule? Do we need to know where every nut and bolt is because, you know, the owner's ADD and he wants to know exactly where every piece goes, you know? Or is it somebody like me who's laissez-faire? You know, that looks close enough to me. The complexity of the project. The more complex the project is, the more detailed the schedule needs to be. The construction manager's philosophy on the details of the schedule. Who's ever running the project, he has a philosophy on what he thinks is important and what's not important to him. Okay, now we implement the schedule. We implement it by who will use the information. So how we put it together is going to be based on who we're going to send it to. What format they want us to use. They want it CPM. Do they want a bar chart? Do they want a PERT chart? How do they want it delivered to them so they can read it? What information we should include. For our owner, we may just give him a weekly summary of what's going on. For our foreman, we may have a day-to-day schedule for him that has what's going on each day. We may even have a schedule for him that's an hourly schedule because that's what detail he needs. So who's using the information makes a difference on what we put together in the schedule. How should the information be organized? Again, we're talking bar charts, PERT charts, CPM schedules, what they want to see, how they want to organize. We looked at several different ones where we organized it by productivity, by activity, by contractor. We can organize it in a whole different lot of ways with a computer. Simple concepts. Yes?
Usually as an owner, I probably ask also the software to do the analysis for the as-built and compare with the baseline so I can see if he's delaying or any potential claims on
Right.
the contractor side. So I have to have everything from the contractor as an owner.
As an owner, we probably want everything from the contractor if they're willing to give it. But if we do that, we definitely have put that in our contract documents that you have to provide us with all that information.
Yeah, because they give you a monthly update, they play tricks on you, and if you don't see it.
Right. And we're not, he's talking about what you can do with the schedules and baseline scheduling and updating and stuff like that. And that's a greater detail than we're going to go into at this. That's the stuff that you actually learn into the, that's fine. It's important to know because each one of these schedules, when we implement it, we're talking about a baseline. We have a start point, what everything looks like to begin with. That's what we're talking about with a baseline schedule. And then as we start to monitor it, that baseline changes. So if I look at it 2 weeks after I started, the original baseline is no good anymore. I'm actually looking at a new baseline at 2 weeks. So what your baseline is and what you're looking at makes a difference. Okay, who the information user. We're looking at upper management, summary information of the project process, owner's status of the overall project, construction firm, detailed breakdown of the work over time for monitoring and control. So different people, you can see the same schedule for 3 different people. They may get 3 different schedules because depending on who we're trying to give the information to. Superintendent wants day-to-day activities. We already talked about that. The foreman wants detail about what's going on right now. Superintendent, suppliers and subs need the information to plan their own work. So you want to be able to send it to them too. So the schedule is just not one thing. It's a multitude of different things that are all the same. And we can present it in lots of different ways. Okay, one of the things to deal with in scheduling is out-of-season work. And since part of this is to talk about scheduling things that can cause you problems, out-of-season work is something you need to look at. One is you just limit your work days. Come springtime in Oklahoma, the likelihood is it rains every other day. So instead of a 5-day work week, we have a 3-day work week. Okay, we've accommodated for the fact that we're just going to be off on certain days because we think there's going to be rain. So we limited the work days. We adjust the activity duration. This is what's preferred. It really makes more sense to say, you know, we're just adjusting. We're going to put 5 days in because that's how many days we think it's going to take. But instead of putting 5 days in, I'm going to put 3 days in because that's all I'm going to work is 3 days a week instead of 5. Now, it's better to put 5 days in and adjust your duration because what if you actually did, you know, what if it's like this winter? If you put in that I wasn't going to work in January in my schedule and you chose to adhere to the fact that I didn't need to work in January because the weather was going to be bad, you'd have missed 30 days of good weather to work in. Okay, you didn't adjust your schedule. You didn't take it in consideration because if the weather's good, if you already have it in your schedule, it's easy. If it rains, it's easy to take out days or add days, but it's difficult to add days to a schedule when you're on a specific, especially if you set it up so I'm going to finish at a specific time at the day the contract's supposed to be ended. Schedule in contingencies. Put into the fact that you're going to have, you're going to have some weather days. You're going to put something in there that says, you might have a schedule item that says, I have 10 weather days. It's just an item that says, you know, we've got 10 weather days in our contract. We just put it into the contract as 10 weather days. And when we use them, we take them out. Oop. Okay, when you present the schedule, basically it's going to be based on who the engineer is, on what kind of presentation, the format. Again, what information should be included. Again, deals on who the user is and how it should be organized. The good news is with computers and proper coding, you can do all sorts of things. Okay? So in most cases, when we set this up, we have an activity, we code that activity so it has a certain number that it belongs to. We may even have another code for it that says it's earthwork, it's something else, and something else. And we put them all into the computer, and then we can select earthwork activities, code number such and such, and it'll spit them all out in that order. Or we can say critical path, and it will spit the critical path out in order first and all the secondary paths behind it. Okay, so whatever we want to do, whoever's format we want to put it in, the computer program will help us do that. Even if it's just you put it into an Excel spreadsheet for a simple bar chart, it'll do the same thing for you. Okay? Now, let's look at short interval scheduling. Sometimes we put together schedules and we put it together on a weekly basis or a monthly basis. So we have this long schedule, but there are times when we're looking at our schedule and something's going wrong, and to get us back on schedule, we may have to do a short interval schedule where we're going to come in and change the schedule so that we can correct something to make us get back to where we belong. Okay? Again, plan the day-to-day work in this short period of time. We're going to adjust, we may adjust the days and say we're going to 10-hour days for the next 2 weeks, guys, because we've got to catch up. Okay, it's a management tool for day-to-day work. Why we want these things. It reflects a short-term concept in our schedule. It's not designed for the whole schedule. It's just designed for a small piece of it. Okay? And usually we put them in because just what we're talking about. We need to get back on schedule. So to complete the overall schedule, we're going to put in a short-term schedule. And we're only going to adjust a small section of the schedule. Stuff that's 3 or 4 months away or outside the short-term interval, that schedule doesn't change whatsoever. Only the small section is what we're going to do, is go in and reschedule that. Which means we may reselect the activities in that section that we want to, divide them up, change the work days, change the hour, change whatever we're looking at so we can get the short-term schedule. Okay? It's goal-orientated. Requires team planning to complete the project on a day-to-day basis. That's basically what we're doing. That's what they're for. We're looking at the individual activities and one specific piece, trying to get it right. Look-ahead schedules and production schedules are the two most common short-term schedules. Look-ahead scheduling means we're going to start, we want to see what's out there 2 or 3 weeks ahead, maybe 1 month. It's not something, I want a look-ahead schedule for the year. Okay? No, it's short-term only. What's happening next week? What's happening in the next 2 weeks? What's happening in the next month because we're behind schedule and we want to make an adjustment. So there's going to be greater detail in this section, right? Because we need to control it better. Greater detail, but there may be limited number of activities because we're not looking at the 100 activities that we're dealing with. In this 2-week period, there may only be 3 activities going on. So we're looking at a small piece of the activity, but we're looking to it in greater detail. And it only addresses the activities that we're looking at in the plan ahead schedule. So if our 2-week schedule only deals with foundations, the painting portion would happen, which happens in week 3, we don't care about. We're not going to look at that. So we're only going to pull out a small piece of the schedule. Okay? But we need to make sure that when we do these look-ahead schedules and looking at it, that we're taking into the fact that we're going to still coordinate that with the regular schedule. We're just trying to see what's going on because we think we have a problem and we're trying to correct that problem, or we have a problem and we're trying to get back into it, but we want it to eventually fold itself back into the rest of the schedule so it brings us back on time. Okay? So we look at this 2-week period, but we also look at, is it going to cause a problem? Is it causing us problems in the long term? And how long is it going to take to get us corrected back into it? Back into the real schedule. Production schedule basically deals with dealing with one activity because we're looking at the production. We have a problem with our production rate someplace along the way. We want to make a correction in it. Or we're looking at a particular group of activities, the earthwork section, because we're having problems with that. We don't know where the problem is, but we want to look at that entire group. Or maybe we're having problems with our carpenters. So we're looking at anything that's in the carpenter section that those people are doing with. So we're dealing with only one trade, or the operating engineers. Okay? These are used greatly by subcontractors. Okay? We're looking for the subcontractor to maybe provide us with this for him because we just have an item in there that says earthwork. It's 10 days. But we want to see his schedule so we can put it into ours to make sure we know what it looks like. Okay? But they need to be tailored to the production, to the characteristics of the end user. Okay? What management information we're looking for. Okay? So it deals with production rates and how they produce, but it's still coordinated to whoever we're trying to provide that information for. If I'm the project manager and I'm looked at the schedule and say, the earthwork was scheduled for 10 days. We're 6 days into it, and it says that you're only 25% complete. We need to look at a production schedule to find out why. Let's look at some back data where it's going, and let's find out what we can do to correct it. Because we have a problem. bar charts, because these are simpler schedules. We may go to a simpler type of system. Data limited production schedules. These are just different sections that we're looking at. Matrix production schedules are just show different pieces of an. There may be 4 points to an item, and a matrix schedule would show us where we're at in each one of those schedules. These are just different schedule techniques that are used for this. Bless you. Okay, so that's through the contract, the scheduling section. And I know it doesn't cover everything that involves in how to produce a schedule and make one work and put everything into it, but it gives you a brief overview of what scheduling is like and how it can help you improve your productivity and manage your resources. Because we talked about at the very beginning, if you can't manage the project, 90% of all construction companies fail because poor management decisions. Okay, I thought I could do it in 10 days and it really took 2 weeks. Or I thought I could do it at this price because I just guessed at the price instead of working up a schedule that gave me a detailed production effort and how many people were going to be involved in the project, and that I had the crews to do all the work and put everything together. I didn't have a plan. All right, now the section on contracts and contract documents that I've put together is just a basic overview of construction management and some contract concepts. The details that were put together in the morning session deal specifically with ODOT. This is just in general all the way around, and that information provided this morning is far better than what this is going to help you with. But this will give you some ideas and methods. Essentially, parties in a contract are owner, contractor, engineer, architect, and subcontractor. Okay? They go together in some sort of combination way where the owner pays for the contractor, pays for the engineer. Here's our beautiful project. And the contractor may pay subcontractors. If we're really, really lucky, the contractor actually gets to talk to the engineer. Okay? Because you notice that there's no little dollar sign between these two, and this is not a solid line. Because in most cases, we have no fiduciary responsibility as the contractor to talk to the engineer or the engineer to talk to us. So if we're really lucky, we get to talk to the engineer. And smart owners make sure that contractors get to talk to engineers, because those are the people that make the decisions on how it works. So we have the owner. In this case, it's ODOT. They're the people with the money. Okay? They oversee the project and work. They could also be the engineer. ODOT does a lot of its own engineering. It also subs out its engineering, so maybe they're not the engineer. So in this case, we've got an owner, engineer, and a contract. Pretty simple line. We know we get to talk to the engineer now because he's the owner. So when dealing with ODOT, in that case, they are usually the engineer. We get to talk to them directly. The contractor. That's the unfortunate person who's paid to build what the owner wants. Okay? We build the plans and specs that somebody else developed, not us. So we use our knowledge for that and the subcontractor to develop the project cost. We come up with the estimate for it. The engineer designs and develops the plans. Specifications need to build. Usually has no contract with the contractor in most cases. Definitely has very little interaction with subcontractors. If you're lucky, the owner pays him to talk to you. If you're not, it's just a lot harder to build the project that you're trying to build to. Or you just build it to the project plans and specifications, and when it's all said and done and doesn't work as well as it's supposed to, it's not your problem. You built the way, you did what they told you to do, even though you told them they were wrong. Okay, the other method that's used these days is construction managers. That's what I teach, is construction management classes. So we're teaching the people that are construction managers. They are not the owner. but are essentially paid by the owner to be the owner. Okay? The owner pays them for their expertise. They, a lot of times, especially in today's new world of design build, they're hiring the designers and the engineers directly through the owner. So they pick out who they're going to use, the owner pays that person, but the construction manager put the team together. So kind of looks like that. Owner pays the contractor, pays the construction manager, pays the engineer, and everybody else talks together. Owner and construction manager are over here, the project's over there. But that's the new system that we use, or a lot of people are using. All right. The documents that we deal with in construction are the Bibles that we have to live by. Okay? We don't do things that aren't in the documents. If we do, we usually cost ourselves money. Okay? They specify the work, the administrative procedures, the arrangements between the parties involved. All that stuff is in your construction documents. They also include agreements on contracts, everything that's going to be in there, how you're going to bid the project, the bidding procedure, so that everybody bids the same and we end up with a, everybody's looking at apples and apples when they're comparing prices. So the documents are the Bible for what we're doing. And if it's not in the documents, again, we're not going to be doing it unless we can get it in the documents. And we don't have to do it. If the owner says, I really want you to do something else, something different than what's in the documents, you don't have to do it, because that's not what he's paying you to do. Okay? They include these items. Usually there's an advertisement for bid, so it tells you who actually can bid the job, what qualifications you actually have to bid the job. The proposal or the bid form, what format you have to put it in. Is it a lump sum bid? Is it a unit price bid? What are the various items that you're going to be doing? The contract, it spells out you the party of the first part, me the party of the second part, is going to do this, the thing of the third part, or whatever. It spells out everything you need to. It gives you information for the bidders, tells you what you need to do, what alternatives may be involved. General conditions, specific conditions, and usually they're drawings, so we know what they're trying to build. We at least get a picture of what it's supposed to look like when it's finished. Okay? With ODOT, they have great drawings. They have great conditions, great special conditions. Okay? They've taken into consideration most of all these things. Most states have manuals that have standard plans and specifications. So if you're told to put in a manhole, you can go to their plans and specifications and see exactly what that manhole is supposed to look like. Okay? So you make sure you buy the manhole that they require, not the one that you like. Okay? So this is all included in the bid document in the documents that we're looking at. The contract outlines the general conditions and procedures, defines the duties and responsibilities, okay? Tells you what you're going to do, says what the owner's going to do. I'm paying you to build a 7-mile road. You're going to build a 7-mile road. I'm going to pay you to build a 7-mile road. It's going to have asphalt, concrete, aggregates, whatever the materials are going to be in it, what types of materials are going to be in it. General bonding and insurance requirements for the contractor. What kind of bonds you have to carry. What kind of insurance you have to carry. It may not have everything in it. Now, ODOT's very good about including soils reports. But ODOT soils reports don't include any narrative from a soils engineer. They only include the boring logs and the design parameters, but they may not include any interpretation. And they may not be sufficient for you to bid the project, because ODOT may say that a boring every mile is good enough for them, and you may want to have information on a closer interval than that because it changes. But whoever supplies that information, and like I said, it's not always included, and this is, I do know that in all ODOT projects, the soils report or the boring logs are included, having worked for a contractor who did ODOT boring, work on ODOT projects. If we were building a bridge, there's a boring at every bridge abutment and every pier location. But all that's included in our report when we send it to ODOT is the boring logs and the test data. There's no interpolation that says, well, you ought to do this, or you ought to do that. ODOT does that. Okay? But there are other projects where you may not get any of that information because it's not in there, because either one, they didn't do it, or they didn't feel like they needed to include it. Bidding, again, we're talking in general contract documents. It specifies what you're doing. It outlines the work that needs to be done and the price you need to quote. Typically, we're either bidding at lump sum or we're bidding at unit price. ODOT bids include both. In most cases, it's lump sum for mob and demobilization, but it's unit price for almost anything that can be quantified. Earthwork, fencing, asphalt, okay? Things that can't be quantified usually are lump summed. Or specialty needs stuff, something that we have to buy to make it work. That's a large piece of equipment. Unit price, cost per foot, linear feet, cubic yards. Quantities, again, the amount needed on each item, on what it's going to take. Quantity owner amounts vary depending on who's doing the quantity takeoffs. The owner, the engineer, the contractor. Each one of those can come up with there's three different estimates there. There could be three different quantities based on the interpretation of how one reads quantities. Maybe the owner sees a 100-foot trench and he just says it's a 100-foot trench. The engineer sees it's a 100-foot trench, but it's got some fire hydrants in it, so, well, there's not quite 100 feet of pipe in it because each one of these fire hydrants requires a different setup. The contractor may see, not only is there 100-foot of trench, but there's elbows, there's risers and all this other stuff that's included, that's in the cost that he didn't take into consideration, that need to be taken into consideration. Okay, if there's uncertainty in the quantities, make sure you get an add and deduct clause in your contract. Okay? If your numbers don't match up with somebody else's numbers, you're going to want something in there that says, if I do more, I get paid more, and if I do less, I'll take less, but I'm going to put it into the system. Especially with earthwork contracts. Add and deduct quantity clauses are very important when it comes to earthwork, because earthwork is one of the hardest things to quantify. Payment clauses are in your contract. How you're going to get paid, who you're going to get paid, when you get paid. They may also determine who determines the quantities. He said, I didn't know that ODOT makes the estimate on themselves and makes a determination. Most places require that the contractor sends you an estimate of what he's completed and you decide whether he's correct or not. Okay, so who's making that decision? And does it include other sections that deal with standby time, liquidated damages, early completion bonuses? You want to know if you're late by a day, how much it's going to cost you. Because there are jobs where people have actually made the decision that says, yeah, it's a $1,000 delay a day liquidated damage, but there's just no way I can do it in 90 days. It's going to take me 120. I'll take the 30-day hit and put it into my bid someplace. Or the liquidated damages may be such that, for every minute you're not finished, it's $1,000 a minute. Well, you're going to work real hard to make sure you get finished in time. Or there's bonus pay. For every day I get done early, I get paid extra. Well, that's pure profit. I can make a whole lot of extra money if I get done finished. If I get finished early, I get a bonus. So these early completion bonuses are important to note too. Dispute resolution. The number one thing you need to know. The contract has without dispute resolutions are rare. Okay? And you don't want to ever sign one that doesn't have that in it. Because if you sign a contract that doesn't have anything in there about dispute resolution, you're at the mercy of whose ever contract you're at and whatever they decide. And you want to be able to pick and choose how you solve your resolutions. Okay? They're very common in earthwork projects. So I would suspect that ODOT has a lot of dispute resolution that it has to deal with. He was talking about change orders of 6 a day that the new person's going to have to deal with. Each one of those change orders is based on probably some sort of dispute resolution. Maybe. But, so you've got simple concept, mutual agreement, a change order. We decided that there was more dirt there than I thought, or there was less dirt there than I thought, and it was a significant amount that I need more money or less money and need to give you money back. So we're going to issue a change order. Didn't quite work. We couldn't decide on the right amounts. Or a common party for this mediation or third-party involvement, one of the acceptable ways for dispute resolution in California when it comes to asphalt testing, is they actually assign a third-party laboratory before they start. The contractor does his testing, the state does its testing. If they don't match, they take the sample to the third party, and whoever his testing matches, they're right, the other guy gets to pay for it. That's in their special provisions clauses now. Okay? That doesn't work, we go to arbitration. Much more formal, usually binding. And finally, if we didn't like the results from binding arbitration, we still have the right to go to litigation. We get to get involved, we get to get lawyers involved, which means we get to start losing money in a very fast pace. And not only do we get to start losing money, but whoever we're disputing about, they get to lose money too. And the only person that gets to make money is the lawyer. Because usually when we get it all said and done, whatever money we made, a third to half of it went to the lawyer anyway, if not more. So those are basically typical dispute resolutions that you would work through. And they're normally always spelled out in the contract. Okay? Almost every contract I've seen lately has at least arbitration and mediation in them. You've always got the right to go to court, no matter what. That doesn't actually have to be in the contract, because you've always got the right to sue. It's what this nation's based on. Okay. The biggest problem that we need to look at when it comes to contracts and where most disputes revolve around is this change condition clause. Okay. Almost all contracts state someplace in the line that you have actually read the contract and you understand the conditions of the contract to begin with. So you can't very well say, well, I didn't know that I was supposed to do that. That's not a change condition, that's ignorance. Okay? A change condition is when something is not what they said it was. A soils report was written for OSU by one company. The second company got the testing on the job, they started the excavation, and nothing that they dug up was what was in the soils report. That's a change condition. Okay? Now, the change condition was actually caused by the fact that whoever wrote the soils report used borings that were 7 miles away in his report, which is why he doesn't work for that company anymore. But that's a change condition. It wasn't what we were looking at. Another example at TU for the case building at the end of the end zone. The piers were supposed to be drilled 20 feet deep, which basically socketed them 5 feet into rock. When they did the excavation, they found that half the building was already on rock. The pier contractor had $100,000 to drill 20-foot deep piers that only needed to go 4 feet now. What was the problem? Was it a change condition? No, really it wasn't. Rock was in the soils report. The problem was the soils report had used one elevation and said, this elevation is 100 feet. The contractor had assumed that 100 foot was this elevation and thought these two elevations were the same. So when they started excavating, the difference in the height was about the difference in why they hit rock where they weren't supposed to hit rock. They went to mediation. The pier contractor, didn't get paid for everything that he had to do because he wasn't drilling as deep as he needed to, but he got a piece of what he was supposed to be doing because the cost changed on him. Okay? Nobody's fault, but it was a change condition. Okay. But they only work when you encounter change conditions, you immediately notify somebody. It's not something that says, I hit rock when I was digging this out and now it's time for you to pay me, and that was 6 months ago or 3 weeks ago when I hit the rock. We had to bring in all this special equipment. Cost you this much extra to do it. Well, why didn't you tell me about it at the time where I could make a decision? I'm not going to pay you to do something that I didn't know was wrong because you didn't bother to inform me. So it's important that you notify your contractors immediately upon change conditions. When you see something that's not there, you dig into an old burn pit that you weren't expecting. That's environmental controls that you may have to do additional testing. You need to let somebody know about it right away, not the fact that we just went right through and dug it out and just include that we had to excavate an extra 100 yards or 1,000 yards. Maybe extra 100 yards, you wouldn't even think about it. An extra 10,000 yards, you might want to get some money for it. So you need to note them right away.